Okay, good morning, everybody. We are just doing absolute values. So as a quick warm-up, try these. Remember, absolute values have to be positive. So do these quickly in your head, and then I'm going to go through the answers. So pause. Okay, check your answers. Are you getting 5, 13? Because remember, absolute values have to be positive. 2, 11, 7, and 4. Remember, in order to get rid of those absolute value symbols, these lines, you are finding distance from 0. So that's always positive. Okay, try these. Use the greater than, less than, or equal to symbols. So again, remember, you are comparing really 82 and 57. So try these. Pause the video. Okay, check your answers. Are you getting that 82 is greater than 57? Did you get less than because 67 is less than 70? Did you get less than? Another less than. Greater than, because 22 is greater than 19, and this one's tricky. This is 61, because the absolute value of negative 61 is just 61. The absolute value of positive 61 is still 61, so they are equal. Okay, so now we're going to solve actual equations. So if there's an absolute value symbol in an equation, it's an absolute value equation. An extraneous solution is just a solution that we reject or say it's not going to be able to work. It's an answer we get, but the answer doesn't make sense. Okay, here's just some rules again. Number 1 means that if you have an absolute value, it has to be positive, meaning it's greater than or equal to 0. Number 2, it just means that, like that 61 and negative 61, once you get rid of those absolute values, two things equal. And 3 and 4 are just saying, if I break things out, if I multiply here, the absolute values, I could have just put them together and taken the absolute value after the fact. And number 4, whatever works for multiplying also works for dividing. And just something to say, when we have it, this is an absolute value equation. A, B, and C are numbers. X is going to stay X. Okay. C has to be positive because you can't have an absolute value equaling a negative. And we're going to have, as long as C starts out as positive, we're going to write 2 equations. Okay, so here we go. Please note, up here is an absolute value equation. Double check that what it equals is positive. Okay, then we're going to go down here and we're going to write it, x minus 4 without the parentheses equals 6. Okay, and then we're going to go here, absolute value of that also equals negative 6. Please note, I do not have the absolute value symbols again. Now they're gone when I write 2 equations. So here I'm going to add 4 to both sides, and what do you get? 10. And I'm going to do the same thing here, and what do you get here? Negative 2. So I am going to get 2 answers, 10 and negative 2. They both work in that absolute value if you were to take these answers and put them back in this original equation. Okay? What that means is we just have, if we have that 4 in the middle, it's going to be 6 units away from that 4 in both directions. And where did I get that 4 from? That original equation. Look where it came from. Okay, this one is tricky. Ooh, why? What's the first thing I told you to check? This is an absolute value, but can an absolute value ever equal a negative? No, it says the absolute value of an expression must be greater than or equal to 0, meaning it's a positive. The equation actually has no solution because it equals a negative. Okay, some sample ones. So here's what we're going to do. We're going to write 2 equations. X equals 10 x equals negative 10. And they both work. That's an easy one because you're just figuring out there's nothing to add or subtract. Okay? This one, x minus 1 equals 4. X minus 1 equals negative 4. So I'm going to add 1 to both sides. And I get x equals 5. And what's my other answer going to be? X equals negative 3. They both work. Okay? This one, you have 3, not 3x. 3 plus x equals negative 3. And I go, wait. It can't equal a negative. It's a no solution. No solution. And you should notice that either right away or when you're recopying it down. Okay? Now, what happens if this is on a number, I want you equal to 0. So you could almost say 3x plus 12 equals 0. Okay? And 3x plus 12 equals negative 0. We don't have anything, so 0 is special. You only have to solve it once. Okay? So minus 12 minus 12. So we have 3x equals negative 12. Divide both sides by 3, and you should get your one answer, because it equals 0, of negative 4. And then on a number line, I want you to put that answer in the middle, the number that goes right after it and right before it. It's got to be appropriate. Okay? And right there. That's all I'm looking for, because that's what it equals. That's how you graph these. That's all you got to do. Okay, now this is solve and graph. This one isn't as quick because now I do have two equations and it does equal a positive, but when I rewrite it without those absolute values, I get rid of the absolute values and I put a positive 8 and a negative 8. I minus 2 and I get 6. And my other solution, when I minus 2 again, negative 10. So on a number line, here's what I'm looking for. Which one of those two numbers, I'm just going to put 2 spots. Negative 10 goes further to the left. And all I'm really looking for is that you know which one is further to the left and which one is further to the right. If you mix up negative 10 and 6, that part's going to be wrong. Okay, same thing here. Now I have d over 3 equals 3, and it is positive, so I know I'm going to have two equations. Equals negative 3. Now this is division, so I'm going to multiply both sides, and I get 9, and I'm going to do the same thing, multiply by 3, and I'm going to get negative 9. And then on a number line, which I'm going to have my two numbers, which one is further left, which one is further right, and just make a few dots saying, yep, I know a negative 9 is actually further left. Okay? So you have some sample problems to do, only 2 through 16 on the worksheet. And then make sure you're checking it before you do the learning check, please. Okay? Have a great day. Please email me if you have questions. Okie dokie. Bye, y'all.